Hi, welcome back. So we are in chapter 3, descriptive analysis. In this chapter, we're going to discuss the second pillars of analysis. First, we'll be looking at a general introduction to something called the EDA, then the measurement of distribution, central tendency, and dispersion. Finally, we'll be looking at a quick introduction to the meaning of bivariate and multivariate descriptive. Let's go ahead and explore the first section, introduction to EDA. Now, before I navigate into the actual details of this outline of Introduction to EDA, the first thing I wanted you to see is descriptive. It's the same meaning as statistics. But statistic is the math language. Descriptive is the academic or linguistic language, in other words. So whenever we are trying to speak about introducing a descriptive model or doing descriptive analysis, mathematically speaking, we are doing statistics. Now, probability has nothing to do in here, which I have earlier mentioned. Probability, usually it is related to prediction, but statistics or descriptive, it is a part of analysis, which completely different, separate tasks. Now, most of the materials, unfortunately, I see them, they make the material a little bit overlap to one another. Now, the first thing to start to understand how to introduce a descriptive model, you need to look at a few important titles or outlines of the steps of doing that descriptive analysis. That's why I'm going to introduce you to something called EDA or explanatory data analysis. So I'm going to share with you the following visual presentation. Essentially, I want to ask you why we need variable. We said before from the previous book, we've come to believe and to understand variable help me to find answer to my research question. Now, having this variable, let's call it variable X. What we wanted to do next is to quantify this variable. And what do I mean with the quantifying? It's by defining something, we call it value, possible value that this variable X can take. Alternative to the analogy of value, I could say possible outcome. Now, more technical terminology, we call it scalar. Any of these terminology are actually the same exact thing. Now, take for example, if I am looking at the gender, maybe the possible value or outcome or scalar, whatever you call it, that could be, for example, male or female. Imagine if the X happens to be a speed, some interval from 0 to 50. These are possible forms how this value can take. So we know now the scalar or the outcome or the value, whatever you call, could have actually two possible or two different groups. First, we will call it categorical. The second, we will call it numerical. Now, the first one, the categorical, has two types. It could be nominal, it could be ordinal. Numerical, on the other hand, could take the form of continuous or could take the form of discrete. It is important to see the difference between these scalars. The first one, nominal, the name is quite intuitive on its own. Take, for example, a gender, like male and female. It isn't any different in the group of male or group of a female. Ordinal, on the other hand, being belong to one group, it differentiates you being on the other group. For example, score at the university. If you score A or B or C is different from each other. Continuous, it is the value when we have an interval like this. For example, speed, height, etc. Discrete, it takes the whole number. For example, the number of children. So I hope this image, it's quite a clear view. Next thing we need to discuss is the sample. Why do I need sample now? Because I define the variable. I know what scalar it is in any of those four possible forms. Now I need sample of subjects from the population I'm interested in, and I collect them to start to measure variable X. For example, I could select M number of samples, right? Then I record the scalar or the values, whatever you call it. The result of this, it will looks like, if I parenthesis that, it will looks like this. This is the second terminology I want you to be familiar with, which is called a vector. what do you need to do on this vector is the subject of this book, analysis. So I hope now you started to see analysis happens on a vector of subject that we measure this variable which had possible outcome. Now this kind of analysis, because it indicates only one vector in particular, we call it a univariate analysis. Now what kind of analysis I can do? Well, there are a number of them. For example, I can study the distribution, which we will explore next. I could study the average. I could study the variance. So all these different parameters I can study on this entire vector as it is. Now, the second scenario happens, two variables, x1 and x2. And what we understand on one vector, it happens to be on the second vector in terms of scalar. And then I have now two vectors, right? I will call it column. So basically, when I say about columns, I mean two vectors come together. And what we need to do on these two variables together, yes, you guessed correct, analysis, like just we did before on one. But this case, we will call it a bivariate analysis. This is where you need to study a kind of a relationship between them. How about if I would have x1, 2, and number of variables? This case, we call it matrix. And once again, I need to do number of analysis. And this analysis, multivariate analysis. Why it's multivariate? Because it has more than two variables to be analyzed. Now, what kind of analysis I'm going to do? Relation, how they correlated all together. Now, I hope this image in nature is quite clear to you, and it gives you clear intuition on the importance of understanding the steps from scalar to vector to column to matrix. That's exactly what I have listed down here, that to answer such a question, you need a variable, right, which we call it the x. And to quantify the variable, you need to define a scalar or the outcome or the value. And many subject of one variable that it's called the univariate vector analysis. You can use distribution, central tendency, or dispersion. And to analyze two variables on the scalar or the vector they have, this is what's called the bivariate or the column analysis. More than two, we are looking at the matrix or multivariate analysis. I hope this introduction of the EDA in general, especially this image of understanding the possible value or scalar a variable can take and why and how is quite clear to you. Let's go ahead now and explore the first on analyzing one vector, and that is the distribution. See you then.